Hi, this is Scott from Consolidated Sterilizer Systems, here to provide a lesson on steam sterilization for beginners. Let's start with some basic terminology. Sterility is imperative in situations where the presence of germs would present a significant safety hazard. Think hospitals, research laboratories, food production facilities, and so on. Sterility is contingent on an item's sterility assurance level, or SAL, which determines the likelihood of microorganisms surviving the sterilization process. The general standard for SAL is 10 to the negative 6th, or a 1 in a million chance of a single viable microorganism surviving. A load, also known as goods, is considered sterile once it has undergone a full sterilization cycle. Different types of goods must be sterilized for different lengths of time and at different temperatures. Once a load is sterilized, it's considered safe to use. One way to achieve sterility of your load is with steam sterilization. In order to kill a cell, you need three things: temperature, or heat, pressure, and time. All three parameters must be met in order for the product to be sterilized. Let's start with temperature. First, you need to raise the temperature to a degree at which the proteins in its cell wall break down and coagulate. Steam heat is very good at doing this because it is a very efficient medium for heat transfer. It requires 540 kilocalories of energy heat to bring 1 liter of water from its boiling point of 100 degrees Celsius and make it steam, which means steam at 100 degrees Celsius contains 7 times as much energy as water at 100 degrees Celsius. All of this energy will be instantly transferred to the product being sterilized when the steam condenses on the object. This heats up cells far more efficiently than air at similar temperatures, which is why we use steam to achieve sterility. Now let's talk about how steam sterilizers work. Steam sterilizers, also known as autoclaves, use pressurized steam heat to kill any microbial life that may be present on a contaminated load. Autoclaves, both large and small, operate using the same principles as your common kitchen pressure cooker. The door is locked to form a sealed chamber, and all air within that chamber is replaced with steam. The steam is pressurized to achieve sterilization. Once a cycle is complete, the steam is exhausted, and goods can be removed. There are 3 primary phases to any sterilization cycle. First, the purge phase, during which steam enters the sterilizer and displaces air. Second, the exposure phase, during which the autoclave achieves and maintains the desired temperature. And finally, the exhaust phase, during which pressure is released from the chamber and the chamber is restored to ambient pressure. A typical laboratory autoclave includes the following components: the vessel, which is the main body of the autoclave and consists of an inner chamber and an outer jacket; the control system, which is operated using a controller interface, not unlike what you'll find on a microwave or oven, albeit more complicated; a thermostatic trap or steam trap, which allows air and water condensate to escape from the chamber; and a safety valve, which is the final fail-safe for the pressure vessel. Lastly, there is a wastewater cooling mechanism, which cools effluent, that is, air, steam, and condensate, before it enters the drain piping. An autoclave might also include a vacuum system, which enables the user to forcibly remove air from the chamber with a vacuum, and a steam generator or boiler, which uses electric heating elements to heat water and generate steam. Next up, we'll talk about sterilization cycles. There are, in general, 3 standard and most popular sterilization cycles: a gravity cycle, which displaces air in the chamber by gravity; a pre-vacuum cycle, which mechanically removes air from the chamber using a series of vacuum and pressure pulses; and a liquid cycle, which is just a gravity cycle with a slower exhaust rate to minimize boilover. It's worth noting that some laboratory autoclaves can perform specialty cycles, such as an air-over-pressure cycle, low temperature or pasteurization, steam-air mix, and rapid cool. Most of these cycles are for goods that are sensitive to prolonged steam exposure. And there you have it, a beginner's guide to steam sterilization. If you'd like to learn even more, talk to a sterilization specialist at Consolidated Sterilizer Systems today.